This is a demonstration of PLM federation. The scenario is where a systems engineer of an unmanned aircraft system, or UAS, is creating a traceability link from a requirement in Doors to a requirement from a supplier of air data computers that is in ShareAspace. The demonstration will show how the Helipal 2 project has rapidly developed an adapter for ShareAspace that can be used from Doors Next Gen. This is an illustration of the use case. The linking technology uses OSLC services to allow a user to search for resources in an OSLC provider application. The link is stored containing the resource URI. When the user needs to see details of the resource, OSLC services are used to request a preview from the provider. In this way, the resource remains in the provider application and does not need to be copied or synchronized. The solution being developed in Helipal 2 uses an adapter called LynxDesigner to convert the OSLC services to the native ShareAspace API, and so turning ShareAspace into an OSLC provider without modification to ShareAspace itself. This approach can be used for any application that has a suitable REST API. LynxDesigner is a model-based, low-code, generic capability provided by the Helipal 2 partner LynxWork and is being enhanced with recommendations from the other project partners. The first step in creating the adapter is to model the resource information. This is then used to specify the OSLC operations for the adapter and their connections to the native ShareAspace REST API. From this, the LynxDesigner application auto-generates most of the adapter code. The remaining fragments of code map between the properties of the ShareAspace resource and the OSLC resource. The adapter code can then be deployed, allowing it to be used by any OSLC consumer application. Now to look at the LynxDesigner solution in more detail. This is the information modeling environment. The adapter for ShareAspace uses the OSLC domain specifications imported directly from the published definitions, so no information modeling was needed. But this environment can be used to define new domains or to extend the OSLC domains for use in the adapter. This is the services modeling environment for LynxDesigner. It shows the model of the services to be exposed by the adapter for ShareAspace. To add services, the resources are simply selected from the information model, and the OSLC services for those resources are then added. For each ShareAspace resource in the adapter, the base URL is specified and the schema provided. Next, the connections are modeled, specifying the native ShareAspace API and any arguments. Finally, the server is configured with the base URL for all the services and the type of authentication. Now the model is sufficient for LynxDesigner to auto-generate the adapter code for the web services that will connect ShareAspace and request the resources. This is the code development environment with the auto-generated code that is almost everything needed for the adapter. The remaining fragments of code still to write are the methods to map the properties and IDs between the OSLC resource class and the ShareAspace resource class. For both of these, LynxDesigner provides sample code. Because the classes are already available in the development environment, auto-completion makes writing this code straightforward. LynxDesigner has also created UI previews, and these can be tailored to give a look and feel of the native application. When complete, the adapter is ready to deploy. The demonstration will now show how the deployed adapter is used to create a traceability link from Doors to ShareAspace. Now looking at the Doors environment, they pick a requirement to be linked to a ShareAspace resource. Then they click to create a link. This displays the selection dialog provided by the LynxDesigner adapter and populated by a call to a native ShareAspace API. Once selected, the link is stored. When the user hovers over the link, if they have the right authentication, a preview is displayed. As before, this is provided by the LynxDesigner adapter and populated by a call to a native ShareAspace API. Clicking on the link takes the user to the requirement in ShareAspace. Imagine in the scenario that the systems engineer for the air data computer has edited the requirement. Returning to Doors, the updates made in ShareAspace can be seen on the link and in the previews. Thank you for watching.